In section 12.4, we're discussing complex fractions, which just means it's fractions inside of other fractions, like this example here. So the technical definition is it's a rational expression that contains fractions in its numerator, denominator, or both. So this is never considered simplified when we have fractions inside of a larger fraction. So there's two ways to simplify these. Method one is done by first combining the terms in the numerator and denominator, and then just dividing the two fractions. So let's try it that way. So what that means is we need common denominators for both the top and the bottom. So common denominators for the top and the bottom. They don't have to be the same common denominator, but we're adding the tops and adding the bottoms. If it were subtraction, we'd do that, of course. All right, so the top, 5/8, we need to make the 2 to be a fraction out of 8. So first, when dealing with whole numbers and fraction problems, we want to write it over 1. And I need to multiply by 8 over 8 so that they'll have a common denominator. And then the bottom, we're going to do basically the same thing, but with the 3. So 2/3 plus 1 over 1 for the whole number. And then this time, I'll multiply by 3 over 3 so that the denominators will match. All right, well, what we'll get then, on the top, 5/8 plus 16/8 makes 21/8. And on the bottom, 2/3 plus 3/3 gives us 5/3. And then this is what we've reduced it down to, is a fraction divided by another fraction. And we have a method for doing that, but let me write it as a division problem. 21/8 divided by 5/3, that's when we use keep, change, flip. So we keep the first fraction, change to multiplication, and flip the second one to 3 over 5. Now this is also where we should look to see if there's any factors that can cancel. And no, 3 goes into 21, but they're not on opposite sides. So we're just gonna multiply the top. 21 times 3 is 63, and multiply the bottom. 8 times 5 is 40. Then we could look for common factors. 63 is 7 times 9, but 7 and 9 don't go into 40, so I think that's it for that one. So that's method 1. Personally, I'm more of a fan of method 2 that we're going to see, but you can use either method for any problem. So method 2, instead of getting separate common denominators for the top and the bottom, we're going to find the overall LCD. So in this one, it's a little different because we multiply all terms by the overall LCD. We're not going to do the top and bottom separately. So let's see what that looks like. So we got 5/8, same problem. I'm still doing the 2 over 1. I'm just rewriting the problem, except putting the whole numbers over 1 so that they look like fractions. The overall common denominator, I don't care anything about the tops, and really the ones aren't changing anything. The common denominator between 8 and 3 is 24, because there's nothing in common, so it's just 8 times 3. So we're going to multiply all the fractions by 24. So 24 times the first fraction, and it's just the tops. I don't want the denominators to be bigger because I'm trying to get rid of these denominators. That's why we're multiplying by this LCD, is so that all the fractions will cancel. So we see we multiplied everything by all the numerators by 24. But I'm not actually going to do 5 times 24. What I'm going to do is cancel, because 24 divided by 8 is 3. So now in this next step, it's 3 times 5 is 15. Now, that would have been the same thing if you had done 24 times 5 and then divided by 8 in a calculator. But we don't need a calculator because the whole idea is that the 8's going to cancel, so we're left with 3 times 5. Now this one, 24 divided by 1 is just 24, so I just need to add 2 times 24 is 48. All right, over here, 24 divided by 3 is 8. All right, so it's just a division problem. 8 times 2 makes 16. Now here the 1 cancels, and it's just 1 times 24, which is 24. All right, so hopefully that makes sense, because once we get used to this method, I find it easier. So I'll do the next example with this method. So we'll get another example of it. Then we add the tops, and it's 63. Add the terms in the denominator, and that looks like 40. Oh, look, same answer as before, but just in a totally different way, right? So it's up to you. Either one works. When I use method 1, so something like this, where there's multiple additions, subtractions in the top and bottom, I'm going to use method 2. So let me write this up here. So method 1 works great if it's just fraction divided by another fraction. That's when I go straight to this. So if it starts like this problem, oh, definitely, I'm just going to flip the bottom fraction. But if I have to do this mess, I would rather do method 2. That is my personal preference. It doesn't have to be yours. But if you see fractions plus another fraction, or a fraction minus another fraction, or in this case, even with these whole numbers, when there starts being additions and subtractions in there, that's when I just multiply the top and the bottom by that common LCD. If we start with fraction equals fraction, we just do keep, change, flip. All right, so hopefully that works for you as well, but you can, either method will work for any of the problems that we're going to see in this section. So let's do a problem that has x's in it, right? This just had numbers. When there's x's, though, the method is still the same. So I'm going to use method 2, which is multiply all 4 pieces, all 4 terms by the same common denominator. So we need to find the overall least common denominator for all the denominators. I clearly need an x minus 1. X minus 1 we already got. We need an x minus 2 as well. The 4, I don't really care about. So that should take care of canceling all these denominators. So I'm going to multiply all terms by this. So we're going to multiply every numerator by this common denominator. So let's see what that looks like. Use a different pen. So the first denominator, it's 2, and I'm going to multiply by x minus 1 times x minus 2. That common denominator, it's still over x minus 1. Oh, look, denominator cancels. That's the whole idea. Minus 4 times x minus 1, x minus 2. I didn't put my 4 over 1 here. You can, but with method 2, we're getting rid of fractions anyway, so I don't need to put the over 1. All right, in the bottom, I have 1 times x minus 1 times x minus 2 all over x minus 1. Oh, look, cancels. And then plus 1, and we're multiplying every numerator by x minus 1 times x minus 2. Those cancel. All right, so let's step back and make sure we see what I did. So every single top of every fraction I multiplied by that same common denominator. And in all that, what that did is made the fractions cancel. That was the whole point and why we chose to multiply by this is so that now there's no more fractions. All right, so now, one thing, let's, we're gonna have to do a lot of multiplying now, right? Let me go with the bottom first so we can sort of see what that's gonna look like, the denominators. Because it's easier in the denominator because I'm just multiplying by 1. 1 times x minus 2 is just x minus 2. 1 times x minus 1 is just x minus 1. And there's a plus sign in the middle. If this had been a minus sign, we would have had to distribute a -1. But with +1, it's not going to change it. It's just going to be x minus 1. No more fractions in the denominator. Good news. All right, let's try the numerator. It's a little more complicated because now it's 2 times x minus 2. So that'd be 2x minus 4. So 2 times x, 2 times 2. And then there's this. This is a FOIL problem. So we need to FOIL or box method. I'm feeling box method, so let's do it. But you can just do regular FOIL too. So I got x minus 1, x minus 2. So this becomes x squared minus 2x minus 1x plus 2. The other tricky piece is that what we get from this FOIL or box method needs to be multiplied by a -4. So I'm going to write it out, x squared minus 3x plus 2. But what goes into this fraction is this being multiplied by -4. So -4 distributes into those parentheses after we did this FOIL. All right, so what do I get? -4x squared plus 12x, because negative times negative makes plus 12x. -4 times +2 is -8. And now, well, at least we don't have a complex fraction anymore. Remember, that means fractions inside of other fractions. So it's not a complex fraction, so we've made progress. Now we just need to combine like terms. Combine like terms. So in the numerator, actually, let's do the denominator first. Let's do the easy one first. X plus x is 2x, -2 and -1 make -3. All right, that was nice. Now, it's not so bad to combine like terms. We have a -4x squared in the top. 12x and 2x make plus 14x. And then -4 and -8 make -12. Now, let's do a little bit of factoring. Because I'm not a fan of that negative leading coefficient, and all of them are divisible by 2, so I'm going to factor out a -2. And what's left then is positive 2x squared minus 7x plus 6. So remember, when we're factoring out a negative, it flips all the signs. All right, so 2x minus 3 goes on the bottom. Well, now this is looking nice. Maybe we should try factoring, not maybe. Like, let's try factoring it. It is an AC method though, because we have a leading term. It's maybe been a while since we did an AC method. So A times C would be 2 times 6, which is 12. So we're trying to multiply to 12 and add to -7. Ooh, that would be -3 and -4. Those two numbers multiply to 12 and add to -7. With AC method, we have to do the splitting the middle. So it's a longer process, but something we gotta do. So we split the middle. We're gonna do factoring by grouping. It's good to review it. In the first two, the common factor is an x, and what's left is 2x minus 3. Here we need to factor out a negative. It'd be -2, and then what's left is 2x minus 3, because factoring out a negative flips the sign or you can multiply out to, see that. All right, what do we get? 2x minus 3 is the common factor, the parentheses match, and what's left over is the x minus 2. All right, so this was sort of side note factoring. Now back to our big old fraction. So in the top, I still have that GCF of -2. Now I know the factored version is 2x minus 3 times x minus 2. And in the bottom, we have 2x minus 3. Oh, well, that's why we did all this factoring, is because now that cancels. So our answer is -2 times x minus 2 with some added restrictions. So one added restriction is that we canceled this, right? So we have to set every factor that canceled equal to 0 though, and that includes the original ones as well. In the original problem, we couldn't have x equals 1 because that would be divided by 0. We couldn't have x equals 2 because that would be divided by 0. So we know x can't equal 1 or 2, but now we have an additional canceling. So we have to set 2x minus 3 equals 0. So we add 3. 2x equals 3, divide by 2, divide by 2. So x cannot equal positive 3/2 as well.